Welcome back to All This Math. This is Professor Parker, and for today's lesson, we're going to do some more geometry. We're going to talk about the remote exterior angle theorem and how to use it. All right, so take a look at this problem we have back here. I have a diagram drawn. It's a triangle with an extended line, right? A triangle with an extended line that goes beyond the triangle, creating an exterior angle. Exterior just means outside. That's all. Ain't no biggie, right? Like we outside, right? You know, this is the exterior angle. This angle is outside, all right? This angle is not on quarantine no more, all right? So this is inside, right? This angle is inside, this angle is inside, this angle is inside. This angle is outside. So because it's outside, the remote exterior angle theorem says this. It says that the measurement of this angle is always going to be equal to, or must be equal to, the measurement of this remote angle and this remote angle added together, So the sum of these two angles is going to be equal to the measure of this angle. All right. This angle don't have nothing to do with this conversation about remote exterior angles, right? Or the remote exterior angle. This is considered, and then you could think of it like this. These two angles, the angle that's the furthest away from those two, and that is also exterior to the triangle, is this angle. All right. Get it? Remote exterior, remote exterior. Remote, like a remote control, controls your TV from far away. All right. You might not really be able to appreciate that because you never had to get up and like go walk to the TV and then turn the knob to turn the channel, or to turn it up or turn it down, or to turn it on or turn it off. You never had to do that. So you might not really be thinking about what the word remote means in remote control and how significant that really is, right? That was a game changer. Back in the day, it was, I always thought it was the rich people that had remote controls, But anyway, we're going to solve for x. So that means we need to create an equation. So we're going to create an equation. So what we're going to do, we're going to say, all right, this plus this is equal to that. Basically, angle B plus angle C is equal to angle, not angle D. We can't call it angle D. We call it angle PDC, or we could call it angle CDP. Because the reason why we can't call it D is because D is a point and is would be the vertex of 1, 2, 3 angles, 3 different angles. So if you just say angle D, I don't know what you're talking about. And nobody else gonna know what you're talking about. You got to be more specific, right? When we get specific with naming angles, then we got to use 3 letters. So you'll know not only the vertex, but you'll also know the 2 rays that form that angle. So that's why, because this angle is not the same as this angle. And this straight angle, this straight line, which is also an angle, is not the same as either of 2 of these angles either. But they all have D as a vertex. Notice that they all got D as a vertex, but they're not all the same. They're 3 totally different angles. So that's why you can't just say angle D. All right, but up here, there's nothing else up here. It's just angle C, that's it. Down here, angle B, that's it. All right, so now let's set up our equation. Our equation is gonna be this angle plus this angle. So angle B plus angle C is equal to angle PDC. So I'm gonna just write that because that's like the formal way to do it, right? Angle B plus angle C is equal to angle PDC, and I said PDC, but you could go the other direction, CDP, as long as those 2 rays are included, this ray, and that vertex D. All right, so this is our equation. Angle B, that's the angle symbol, that's an angle symbol, that's an angle symbol. Angle B plus angle C is equal to angle PDC. All right, now we're going to replace the angle letters or the angle names with their actual measurements. So B is 7x plus 5. All right, so we don't know the actual measurement. Actually, not yet. We about to. Once we solve for x, we can figure it out. Just plug that number in there for x and then just do the math, So angle C is going to be 84. And then that's equal to angle PDC, which is 17x minus 1. All right, so make sure you understand how I set the equation up. This 7x plus 5 is this angle right here. This 84 is this angle right here. I got my equal sign. These 2 angles added up must equal that. That's what the remote exterior angle theory says. So in geometry, you're given a whole bunch of theories, a whole bunch of rules, a whole bunch of laws, postulates, whatever we want to call them. You have to understand the postulate, and then from understanding it, then you're able to create an equation. So because I understand what the remote exterior angle theorem says, I can then take that information and then look at this triangle and then look at this extended line and say, all right, this I'm about to set up my equation. And then I set up my equation because based on a remote exterior angle theory, it says that this angle plus this angle has got to be equal to that angle. Straight like that. It's got to be. All right. So that's why I got 7x plus 5 plus 84 is equal to 17x minus 1. And now I'm just doing algebra now. So now really like the geometry is over. Now I'm just doing, I'm in algebra 1 again. I'm just doing algebra 1 now. All right. So I might start off by like combining like terms on the left-hand side. I might add this 5 with this 84. So now I got 7x plus 89. And then I got still 17x minus 1 over here. And then what I'm going to do is I'm going to do something called transpose, right? Because there's many ways to solve equations, right? Many mathematically sound ways to solve equations. Transposing is when you basically just pick up a term and move it to the other side of the equal sign. But when you do that, it's like a shortcut, right? But when you do that, you have to change the sign. Switch the side, change the sign. Switch the side, change the sign. I remember a young brother named Hanif from South Philly, like 15, 16 years ago when I first started teaching. He said that in class one day. I never forgot it. It was a game changer. Switch the side, change the sign. Switch the side, change the sign. All right? So I got 7x minus 17x is equal to negative 89 minus 1. Now, 7x was already over there. Where'd this negative 17x come from? It was on the right-hand side. Switch the side, change the sign. Move it over to the left-hand side and make it negative, minus 17x. 89, move it over to the right-hand side, make it negative. Now it's negative 89. Don't forget to change the sign. If you use this trick, this math trick, don't forget to change the sign. If you forget to change the sign, your answer is going to be wrong. You don't want to get a wrong answer, all right? Remember to change the sign, all right? Otherwise, just do it the standard way, right? Just do minus 17x on the right, minus 17x on the left. Minus 89 on the left, minus 89 on the right. Do it that way, which is basically what we about to do anyway. That's why I said this is like a shortcut, because you end up doing 7x minus 17x anyway. You end up doing negative 1 minus 89. Well, negative 89 minus 1 is the same thing as negative 1 minus 89 anyway, right? So 7 minus 17 is going to be negative 10. So that's negative 10x. Negative 89 minus 1 is going to be negative 90. All right? Now, the way I get x by itself, I got to get rid of this negative 10. I got to get rid of negative 10. So this is negative 10 times x. So the inverse of that would be to divide. The inverse of that would be to divide. Divide by the same exact number. Divide by negative 10 on the left, and also divide by negative 10 on the right. Boom, boom. That becomes 1x. Negative 10 divided by negative 10 is 1. Anytime you divide any number by the same exact number, the quotient is always 1. So that's 1x, which is just x. And then negative 90 divided by negative 10 is going to be positive 9. So we got x equals 9. All right? And that's what we're supposed to do. Solve for x. X is 9. But let's check our work, though, right? Let's check our work. Because we want to make sure that this angle plus this angle is equal to that angle. So if x is 9, then that means that the measure of this angle is going to be 17 times 9 minus 1. 17 times 9, this is how I do the mental math. Let me show you this, right? Let me check this out, right? 17 times 9, I use the distributive property. I break 17 down into 10 plus 7, right? 10 plus 7. And then I do 10, I use 10 and 7 because 10 ends in 0. And multiplying by a number that ends in 0 is always easy to do because you could pretend like that 0 is not even there and just multiply the number in the tens place, that 1, by the number you're trying to multiply by, get that product, and then just throw the 0 on there. So watch this. 10 times 9 is just 1 times 9, which is 9, and then attach the 0, that's 90. And then 7 times 9 is 63. So you really add in 90 plus 63 to get 153, right? So 17 times 9 is 153, right? Because that's 10 times 9, which is 90, and 7 times 9 is 63. 90 and 63 is 153. So this is 153 take away 1. 153 take away 1 is 152. All right, so that angle is 152 degrees, right? So now let's see what this angle is. Let's see what this angle is. That's 7 times 9 plus 5. Now we got to know our multiplication facts for this. 7 times 9 is 63. 63 plus 5 is going to be 68. All right, now, remote exterior angle theorem says that this angle plus this angle must be equal to this angle. So if this angle is 84, and this angle is 68, just add them up. 80 and 60 is 140, 8 and 4 is 12, 140 and 12 is 152. That's good money. That's good money, right? These two angles added up equal that angle out there. All right? So that's proof that based on the remote exterior angle theorem, that x is 9. That's proof that x is 9. So we good. We good. We finished. All right. X equals 9. All right. So now we are finished that. Now I showed you how to do this type of problem. I showed you how to solve for x, set the equation up, how to look at the diagram and understand the information and set the equation up. But if you don't practice, you're going to forget and you're not going to know how to do it. And it's not even going to matter. All right. So you got to go practice. So go practice, go do some homework problems, or just go online and find some practice problems under remote exterior angle theorem and get to work. All right. You go practice and I'll catch up with you on the next video. Peace.